But my name is Paige Bailey. I work for Chevron in Houston, and I'm also attending grad school at Rice University. I recently graduated from Rice with a Bachelor's of Science in Geophysics, so nothing particularly computery, but I have a deep-seated love of Python. I've been using it for the past around 4.5, maybe 5 years, and got started with it because of its integration with ArcGIS, which is a mapping utility. It's used in industry quite extensively. It's kind of expensive if you are looking for a personal solution for mapping, but it's definitely a powerful tool. And I just kind of never looked back. After finding out what it can do with ArcGIS, finding out what it can do for science and mathematics and basically any sort of engineering, Python's just kind of been my language of choice. So I also have with me Walker Hale, who will be co-instructoring and acting as a TA. So if you have any questions throughout the lecture, just let us know. The general format's going to be, I'm going to run through the slides very quickly. Hopefully people will ask questions. If you see something you don't recognize, let us know. And yeah, but Walker, do you want to do an introduction?
Okay, so I work at the Texas Medical Center, at the Human Genome Sequencing Center, where we produce next-gen sequence data.
I guess in terms of how I use Python at work, Chevron's not really in the business of app development or website development. Usually we contract external vendors to do things like that. But we do use it for small-scale scripting tasks, so any sysadmin work, and also its integration with ArcGIS. So if we have a process that we want to do on a bunch of shapefiles, which are bits and pieces of mathematical, bits and pieces of map information, then we would use Python to sort of analyze that data. And I think also our earth scientists use it at times whenever MATLAB isn't quite doing the trick, or they want to ensure that whatever algorithm they create, they know precisely what it's doing at every moment in time. And Python is also better at working with large amounts of data than MATLAB is. MATLAB can choke pretty easily. So just, again, let's get started. I have about 67 slides, so that's a lot. I'm going to run through them very quickly, and I want this to be a dialogue. So at the end of the lecture, we're going to have sort of a workshop situation. If you don't have Python downloaded on your computer, we'll have you with Python at the end of this lecture, provided you want it. But we also want to make sure that you are understanding the majority of what's happening on the slides. They'll be placed online as a reference too. So let's get started. As a refresher, this class is intended for folks who already have some sort of experience with programming. So it might not be with Python necessarily. It's just kind of a basic, you know what a data type is. You know the difference between a string, an int, a floating point integer, a list, a dictionary, a tuple, those sorts of things. But just in case you've forgotten, or you've forgotten how Python makes them look, there are some examples. So booleans, strings, tuples, lists, dictionaries. That's in general what they look like. And you can perform a variety of operations on these data types to sort of get your programs to do what you need them to do. For loops, again, pretty standard for any language. You have a list right here of Beatles names, right? And for each Beatle in this Beatles list, you're running through and you're printing that name. So John, Paul, George, and Ringo, standard for loop. Then there's also a while loop. So for example, a temperature, and it runs through, counts off whatever temperature your beverage would happen to be, and until it gets to be 112, it decrements, And then when it hits 112, it prints off that, you know, your beverage is good to go. You're good to drink it. So standard for that. And that's an expression of Python syntax, right? Like you have the colons at the end. It's pretty readable format, you know. There you go. So also conditionals, if, elif, and else. So this would be asking for raw input. So user, it would flash, please enter the answer to life, the universe, and everything to the screen. You would obviously answer 42 because what else could it be? And then it would print off if you can, or depending on your answer, if you didn't say 42, you would get these different inputs. So this is something that I also went over in my talk earlier today. So you would have a user input as a drink for its function, and you would get these responses back. So just descriptions of Python syntax. And then there are Booleans. True and true would output true, false and true would output false, 1 and 2, 2, 0 and 2, 0. And these are all sort of described in Python documentation as well throughout. So,
note that,
yeah, go for it.
So, like a lot of other scripting languages, Python will accept in a for loop, in an if statement, things other than just true and false.
Mm-hmm.
Whenever you have an if statement or a while loop, an expression is considered to be false if it is either the literal false, a numeric value of 0, a container that is empty. That can be an empty list, an empty tuple, an empty dictionary, or an empty string.
Mm-hmm.
Those things are all false. Additionally, if an object is a user-defined custom class that defines some kind of Boolean concept, that class could declare itself to be false. In all other cases, the expression is evaluated to be true, which is sort of intuitively what you would expect it to be. That way, if you've got a list with a bunch of stuff in it, and you've got a while loop, you can say, while my list. And while I'm processing that while loop, I keep removing things from the list. When the list is empty, the while loop terminates. And that translates over to Paige's tables over here. Notice when you're using the keywords and or, you'll get a value that isn't necessarily literally true or false. What Python does is it shows the value in your expression that decided the answer to the question. So if you get x and y, well, if x is false, we have our answer right there. We don't need to look at y. So the value would be the value of x.
Right.
If you've got x or y, and x happens to evaluate to true, well, again, you have your answer as soon as you saw x was true. The value would be the value of x. Otherwise, it would be the value of the second, y. That's why if you look at those things, I mean, if you interpret true or false the way I just described, the tables are always getting the right thing. But that's why you'll see things like 0 or 1 equals 1. That could have been 0 or 5 equals 5.
Excellent. And actually, so something that we did in the workshop earlier this morning was that we kind of went around the room and sort of did a brief introduction of ourselves, like very brief. We do have a lot of people here, but just yourself, how long you've been working with Python or whatever computer language, what kind of familiarity you have with it. And that kind of gives us a feel for the experience levels, right? Like, if we have a bunch of people in here who are all hardcore Django developers or like do scientific Python on the regs, then maybe we should just focus on some things preferentially to others. But yeah, let's go around the room, kind of do a brief introduction. Would you mind starting?
Sure. I've been doing PHP for 10 years.
Okay.
Python.
It's Booleans. And now we're going to break into something called Code Sculptor. So an additional question, how many people do not have some flavor of Python downloaded onto their personal laptop? Okay, so there are a few. And in terms of everybody else, do you just have sort of the vanilla version of Python that you download from the Python website, or do you have some sort of specialized development environment like Anaconda or Canopy?
So everybody has a specialized environment.
Raise your hand.
Okay.
I have one in your
All right.
Excellent.
And so all the rest of you, except for two, have vanilla Python that's provided by. Okay, and how many people installed vanilla Python?
You.
Most Unix operating systems have Python pre-installed, but it's usually an older version.
Yeah, and I think Macs also have Python installed. So if you open up a terminal window in your Mac laptop, you type in Python, it should pop up. It's the same story for R. But yeah, so it sounds like most people have some version of Python. And there's always some sort of difficulty whenever you do things like this and want to have workshops with version control, right? So some people might have 2.7.8, some people might have 3.4.1, and just to make sure that everybody's on a level playing field, I wanted to have a standardized sandbox sort of environment where people could play with things. And the best one that I can think of is called Sculptor, and we can pull that up now. So I'm assuming that everybody is on the internet, right? Like everybody's constantly connected, hopefully. If not, you connect to the guest Wi-Fi, and then your username and password are available on the back of your name tag. But this codesculptor.org, codesculptor.org is a Python environment that was created by a team from Rice University. So whenever I took Python at Rice as an undergrad, this was what they had us using. This is how they had us turn in assignments even. So when you click this right-pointed arrow, this run arrow, it runs whatever is in the left-hand side of your browser window. So this is just importing a simple GUI that says welcome. When you click it, it says good job, and you're like, yay! And you can make modifications to it, like you can make it blue instead of red. You can say gigum instead of welcome. You can, do whatever you want. You can save it. It gives you a unique link that you can copy. You can send it to everybody that you love and say, oh, look at this cool thing that I did with Python. All you have to do is click the run button, and it will go for them as well. And each time you modify it, right? So I could change it to red, save it, change it to green, save it. And it keeps the standard little code here, but modifies this number. So if you want to go back a couple of versions, you can just type in the original, and it gives you that instead of the modified version that you had made. So it's a pretty decent way to track how code changes and to be able to just send a link, right? Like to show someone what you've been working on and doing. So for the majority, if you want to play along and you don't have a Python environment to work with, definitely use Sculptor. It's a way to have dynamic visualizations. And it does use Python 2.7, so this is not running on 3. And if you see a print statement anywhere, maybe not. But yeah, a way to check to see that it's not running on Python 3 is that you have to type in print space and then whatever you want. So there we go. So Sculptor is developed by Scott Rixner of Rice University for use in Comp 200, which is our beginner sort of, you're a computer science major, and you haven't really had much programming experience before, but time to learn. And it's based on CodeMirror and CodeMirror and Sculpt, and I put links to them in the slides. If you want to experiment more with this tool and you want to learn more about Python in general, they're also currently sponsoring a Coursera course called An Introduction to Interactive Programming in Python. It's running from around mid-September, so it's gotten started, to mid-November. And you can just go online, register for it, get access to all the materials. You don't have to complete them, but it's a great way to learn Python. And it should be part of a 3 or 4 part programming suite sponsored by Coursera that is intended to teach computer science fundamentals. So everything that you would learn as part of the first year of an undergrad computer science curriculum, that's what it's intended to convey. So definitely recommend that. Interacting with Code Sculptor. Those little buttons that you see on the left, the first one is run, second save, then fresh URL, open local, and reset. So run we've already seen. You type stuff into the left-hand portion, you click run, and depending on whether Python understands it or not, it'll give you an output or it will give you an error message. And if you save it, it will give you a unique URL that you can then send to anybody. They can put it into their browser and see what you've been working on. You can get a fresh URL if you have decided that you're completely through with whatever URL that you've been currently working on and you don't want people to see, how the development process has gone through. And you can also open a local text file using Code Sculptor. So I don't think it can be anything too incredibly massive, but you can definitely do CSV files, text files, and a couple of others, maybe even URLs, but I'm not certain on that, so don't quote me. And the stuff on the right is documentation specific for Python and specific for the tool itself, a few demos that you can see, and then also something called a viz mode that we won't discuss very heavily. But the demos portion, if you're looking for ideas for things to do using Python, the Hall of Fame is a pretty decent place to look. Like the DDR clone, you can scroll through and you can see that it's pretty extensive, right? Like lots and lots of functions, less than 1,000 lines of code, but still doing some complicated things. And when you hit run, it's a DDR clone. And also, none of you can hear this because we don't have the speakers set up. But yeah, so the never-written role-playing game, what is that? Yeah, there's music involved with this. So, and you can also see that I really, really suck at Dance Dance Revolution. But yeah, so with less than 1,000 lines of code, right, you're capable of making something like this using Python, and you can run it in a browser without even installing Python locally onto your machine. And actually, everything that this game is using to run, we will discuss in this 101 tutorial. So import simple GUI. Actually, yeah, I think that the only libraries it's using simple GUI, math, random, and URL lib2. Those are the only things. And loading an external MP3. What? Yes, and it's available within the Python package index. You might have to download it yourself, so like pip install, it didn't go?
I thought in the Coursera course you said the simple GUI was specific to Code Sculptor. That could be one.
Yeah, I saw it in the Python package index when I was using it, but it didn't work? Okay. Okay. Yeah, it might not be available then, but if you'd like to play along with it today in Code Sculptor, I thought for sure. But yeah. So definitely a good place to look for inspiration on different Python materials, different programs that people have already created. Tetris, Prototype, Simple Music Player, all these different sorts of things. And it's great whenever you're first starting out learning a language to see code samples, I feel, because you might know how to do it in your favorite language, right? Like Java or C or something of that nature. But being able to see how the syntax plays out and how the structure, the language determines the structure of your program, it's good stuff. So back to the slides. And thanks for the question. So breaking into objects, I guess this is the first non-101 kind of topic to cover. In the real world, objects have things that you can do to them, so actions, and words that describe them, like properties. And in Python, the things that you can do to an object are called methods, and the words that describe the object are various attributes. So think of something like a cup, right? Like you can say certain things about this cup. You can describe its color, you can describe how big it is, you can describe its weight, all these sorts of things. And that would be an object, right? So this cup is an object, and it has those various attributes. I used a Tesla as kind of an example of my object. So I wish it was my car, but if you call this Tesla my car, it can have a color, a max speed, an electricity usage, a weight, a price, and you can display them by using this sort of syntax and assign values to them. So the powerful thing, or I guess, you can also have methods, so sort of verbs ascribed to this object. You can drive it, you can wash it, charge it, tune it up, and there are things that you can do to an object. And they take the form of functions. So in Python, a class is like a description or a blueprint of a particular object. So if you have a class that's Tesla, you can have a color, a size, a type, a manufacturer, a direction, and then like that would be an example of driving in circles, right? Like you go north, it goes west, west, south, south, east, and then else it would go north. And the reason that this is valuable is like, so say that you had any sort of car, right? Like you would have a standard set of methods that you would want to ascribe to those particular sorts of objects, right? Like you would want to be able to do a variety of things. Yes?
The word self in there, I mean, is that just sort of the nomenclature of how to refer? Because if you go back to that screen, so you have class and then you've got those, are you using class in that?
I think that might have been a typo. Like,
yeah, I think really what it was
self. Yeah, self. So drive. Think of it as drive. Open parentheses self. And.
Oh, and then in circles was just a comment.
Yeah.
Okay.
Yeah.
So in object-oriented programming, when you have an object,
let me make that.
And all special methods are surrounded by double underscores. When you see something with double underscores on the other side, that means you're interacting with the machinery of the Python runtime itself, as opposed to just user-defined functions.
Cool. So moving into modules, list methods, pretty much. Like I might show you a few that you haven't seen before. But if you've seen any of them, right? Like if you've seen range and you have a way that you've used it that you think is interesting or new and exciting, or you've used it at work and you didn't particularly like it, just like feel free to speak up, because this really just is kind of like a basic run through, and then more of a discussion about how to use Python and what you would like to use it for and how we can help you get what you need to get accomplished. So range is basically just running through and giving you a list with a specified version of numbers. So like range open parentheses 5 would give you a list with 0 through 4. And Python obviously starts indexing at 0. Range 1 to 10, again, gives you 1 to 10. So, yes.
If you start using NumPy,
Mm-hmm.
you know, what you're showing up here, it's all, you know, your standard Python language,
Right.
If you start using NumPy, can you intermix NumPy commands with regular Python commands?
Yes, but you've got to be careful. So you could take.
Yes.
I just wanted to point out that range functions differently in Python 2 and Python 3, so someone may try to do what you're doing up here, replicate what you're doing up here, and run across the top of there in Python 3.
Okay.
So for Python 3, if you want to see the corresponding array of invoking the range function, just wrap the range function in the list function. There's this concept of iterators and iterables and all this. So for loops will take anything that isn't iterable. There are two kinds of iterables, iterators and containers. The old range function in Python 2 gave you just a list, a container of integers. The problem is that there's a scale below, like your crazy scale, that's still above Paige's scale, where actually filling up memory with a bunch of integers just to step through them and use each one exactly once is hideously inefficient. And so Python 2 introduced xrange to say, let's instead give you an iterator that's just going to be a machine, like a toaster. Push a button, another one pops out. Push it again, another one pops out. And that would let the for loop drive much more efficiently without wasting a ton of memory to just get a loop variable. Xrange was renamed as range when we moved from Python 2 to Python 3 because Python 3, the philosophy shifted from let's have methods and functions that return lists to ones that produce iterators, because that allows for the possibility of much more efficient code. And then when you explicitly need the list to be generated and all that memory allocated, just use the list function directly. List will take any iterator or iterable and give you a list of whatever would be generated. And as long as your iterator was finite, you're good.
Yeah. And also, in terms of people who have vanilla Python installed on their personal machines, is it version 2.7 or is it some type of version 3? So who has version 2 installed?
You know, your machine right here.
Yeah, on your machine right there.
I've got both.
You got both? Okay, cool. Just trying to get a flavor. There's always a great deal of, infighting going on between people who really like 3 and people who really like 2 and people who are forced to use one or the other because of work.
Who has both? Wow.
Yeah.
I just migrated all of our code over to 2 and 3.
Yeah. Cool. Yeah, so the version that's currently, or at least the version of ArcGIS that we're using at work, it has 2.7 sort of incorporated into it. But apparently they're moving to 3. I just found out today, and that's exciting, new and exciting. And QGIS also uses 2.7 and not version 3. So I would recommend that if you're first starting out with Python, to start with the latest of version 3. But again, that's kind of a fighting situation. So, all right, and then a couple additional list methods. So append, extend. If you would like to add things to the end of the list, that's the way that you would go about doing it.
Please, whenever possible, if you're going to modify a list and make the list either bigger or smaller, make your changes to the end of the list,
Yeah.
not the beginning of the list.
Yep.
Because if you make a change to the beginning of the list, either inserting an item or deleting an item, then everything in the list has to lift up and shift over one spot.
Mm-hmm. And the difference between append and extend, you can see it kind of demonstrated here in the middle. Append, if you would like to add a list to the end of a list, append would just make it as as a separate entry, right? So it would embed that list that you're asking for within the original list. Extend would be giving each of those elements in the list its own separate place in the original list. So this one has 1, 2, 3, 4 items in the list, and this one has 1, 2, 3, 4, 5, 6. So there you go. And that would also be how a dictionary would look if you were to extend with using a dictionary or a tuple at the top. So you can also insert methods into a list at any given position. This goes through and kind of shows if you have an original list with A, B, and C, and you want to insert the value of X into the second position, that's how it would look. Or insert Y into the first position, insert Z into the fifth. Removing versus popping. So this one, you would remove the first instance of B, and then that would be popping out, a particular value.
If you don't specify a number on pop, it's the opposite of a pen.
Yeah, so it does the last item, right? Yeah. Reverse, sort, and list. And again, if you have any examples of ways that you've used this in the past or ways that you think that you could use it, just feel free to speak up. So reverses items in a list, obviously. Sort would sort them from least to greatest. And list is just an empty list, right? Like it goes through and you can insert various things into it. So if you have a dictionary, right, like print list of 1, 2, 3 to 4, it would just spit out that at you, a list with 1 and 3, because it would just want to return the keys. String methods. So a string is an immutable sequence of characters. With 0 characters, it's an empty string, and it's indexed with sequential integers. So again, if you were to go into Code Sculptor and Control-A, print whatever, Dumbledore, and you wanted to index a certain value, all you would have to do is give whatever position you would want. So this would be 0, 1, 2, 3. It would be the B, hopefully returned. Yes. And you would be able to index through each specific character in that particular string and get the value that you determined. If you want to do a slice, you could do that and give you from the second value to the third, because it would chop off it would be up to, not including the third value. So those are an example of some strings. You can use single quotes or double quotes and multi-line. And that's a typo. That should have a couple more apostrophes. And you can also do special methods on them. So that's a character return or a carriage return, a horizontal tab, a vertical tab, new line, form feed, those sorts of things, depending on whatever your need is.
You're going to use those triple-quoted strings in 3 common places. One is documentation. So doc strings at the beginning of classes and functions or the modules to see what it does. Another one is test code. Say you're writing a program that parses, say, CSV files, and you write a test for it. Well, rather than having your test cases be separate files, you could embed your test cases in your test code, as each one is just a triple-quoted string that would have been the contents of that file. And the third obvious case where this happens a lot is interacting with external systems, especially SQL, where you might have a parameterized query in SQL expressed as a triple-quoted string, and And it's so much nicer than a lot of the other languages that don't support long strings, because you don't have like string plus string plus plain string plus string to represent a 20-line query. It's just nice and readable.
Yeah. Whenever in school, whenever they had us do documentation within our program, it would usually be the triple quoted string would be used to define what a function is doing, right? So you would have def function, and then immediately beneath it you would have sort of a description of what its process was actually intending to do.
When you do that, the Python machinery uses that information for you. Whatever you have in a triple quoted string right after a module, so it's like the first thing in your module, or the import statements, or the first thing in your class right after the colon, or the first thing in your function right after the colon. In each of those cases, the value of the triple quoted string is made a property of that object as the underscore underscore doc underscore underscore.
Mm-hmm.
And so if you're dealing with any kind of environment that is providing a help system, this could be an IDE, this could be IPython, this could be the built-in help command that's in the interactive vanilla Python. All of those will use the value of that doc string when the user asks for help. It's also just a better style of programming that at the beginning of every program, every file that you made, the very first line in there was something saying what this file is about. Because at some point, somebody is going to be going through your code base looking for something, and as they open file after file after file, they're going to really appreciate that there's something at the very top that told them whether this file is what they're looking for or they should just move on.
Or heck.
A lot of programmers are lazy, and to find out what the file really does, you've got to read the whole thing, or at least read halfway through it to find out, oh, this isn't what I'm looking for. I've got another 50 just like this before I find what I'm looking for.
Yeah, or it could just be you, 2 weeks later after you've slept, or like 2 hours later after you had lunch and just want another cookie, right? Like, it's having documentation embedded within your programming is just such an important practice. And I mean, one of the nice things that people always praise about Python is that it's so readable, right? In comparison to something like C++, Python is just like you look at it and it's reading English. But still, like no matter how easily readable your language is, you always need to incorporate documentation. And this just kind of goes through str, open parentheses, converts whatever values are inside the parentheses into a string. So this just sorts of classifies it. And print string, that just returns the class. Right, so join, split, and partition. So this, you can see, you're just going through and adding particular things between the values of whatever items that you have in your list, right? So this is saying that you would want to embed a comma between every value in this. And again, all of these slides will be available on GitHub after doing extensive work to make sure that there aren't any typos immediately following the presentation, and you will be able to have access to them as needed. So capitalizing upper and lower. If you have a string, varying cases, and you want to capitalize it, you would use that. To make it all upper, you would use dot upper, open parentheses, dot lower, open parentheses. Find, index, and replace. And this also is incorporating rfind. That just searches through a string and finds a substring or replaces a substring down here. So starts with, ends with, and is digit. So that, Walker and I were just looking through this. Has anybody used any of these in their workplace? The starts with, ends with? I do. Whenever we search through well header files, for example, which are usually text files, you look for things that would be standard for the first bit, and then afterward you have specifics based on how they're sidetracked. So starts with is always important for that. Or if you're looking for a specific well, ends with. Dictionary methods. So a dictionary is also changeable, mapping of keys to values, and a dictionary with no keys is an empty dictionary. Also known as associative memories, associative arrays, or hash maps in whatever your programming language of choice would happen to be. They're indexed by keys, but when iterated upon, they are iterated upon not in an ordered manner, so you can't really index them, right? Like there's no way to index a dictionary. And these are all examples of how they can be used within Python.
Well, I mean, the dictionary indexes itself. The time index is a way to quickly get the value out.
Yeah.
But if you want to dump a dictionary in order, which you should always do if you're intending a human to look at, or you're dumping it to a log file. What you can do is use these sorted built-in functions. Sorted takes something and gives you the sorted version of that. So given the dictionary, sorted the dictionary will give me the keys
In
in
alphabetical,
order.
yeah.
And then I can use that to get the values if I'm driving a for loop. Or if I just want to just dump all the items, I can just go sorted the dictionary dot items, or well, inner items in Python too, and they'd all fall out in order.
Yeah, and I think sort is probably coming up pretty soon. But yeah, so dict just returns an empty dictionary. You can also list the sort through a dictionary and get the value for a particular key, right? So this is looking at this dictionary. You give it the value of 2, and it's returning B because that's the value of the key 2. So you can also use the .get command. And if you .get something that isn't contained within the dictionary, then it would return a none or a not here. So has key, returns a Boolean, and it just cycles through a dictionary, determine if a key is there. You can also...
The short form of that is you can just go in.
Yeah.
Just go, my key in my dictionary.
When you do that, is that like an order and lookup, or it's going through,
No.
it's looking at keys, or does it hash and see if
It's under the hood, the Python dictionary type is super fast, based on hash map, and is what all of the rest of Python is based on. So Python modules and pipe and all user-defined objects are really just a bunch of dictionaries pointing to each other.
Yes.
On the last slide, the word none, was that a global token like false? And when you're asking it to get a value that's not there, it's
Oh,
returning.
none?
Yeah.
Is that something that I could use a global token to compare?
Yes.
Yeah.
Okay.
Yeah, there is. None is, just like true and false, are keywords in Python that are this one global thing. And none is the equivalent of like null in SQL.
And I know those sorts of things get kind of confusing. Do we have any R users in the room? Like R, the statistics language? You in the back? So one of the problems that I have with R, and there are everybody has their particularities, right? But I really dislike that in R you can redefine things that are considered to be constants, right? So if I go to Code Sculptor and I try to say, well, I want 4 to equal foo. I want 4 to be the string foo. Let's do this, and let's print out 4 and let's have that work. Python will throw up a syntax error because you can't assign a string value to a literal, right? Like this is an integer. It's intended to be an integer, and that's what God said, right? Or whatever.
You can't have 4 equal to 8 either.
Yeah, it's a standard thing. Also, it works with define, right? So like if def is used to define a function, that's its purpose. And I can't just have def equal whatever I want it to be. It has a specific purpose, and it's got sort of a shield around it to protect me from myself. In R, you can redefine anything, right? Like you can say, I want A to be B, and it would work. You could do it for Booleans too. Like you could say, I want true to be false, and it will totally let you, and it won't even throw up anything to the effect of, well, it's already been defined. Are you sure you want to redefine it a different way? Like it has no protections for you against yourself. It assumes zero user error, and usually users are the people creating the majority of the error.
Schizophrenic.
Sounds about right.
I wanted to ask, like, how you deal with lack of user-land constants, like, in the business environment. Like, I would be comfortable with the honor system if I'm going to write this variable in caps, and you're not going to overwrite it. Like, are you guys using libraries that bring that functionality in? No.
So there's a saying in the Python community, we're all consenting adults. So if you want something to be a constant, you capitalize it. If you want something to be private, you prefix it with a single underscore. And then we just agree to respect those conventions. This works as long as everybody behaves as adults.
People don't always behave as adults.
Yeah, I don't think you guys think about that.
Well, and that's why if you want to hire a big team of programmers that you don't trust, use Java.
Somebody tweet that. Hashtag PyTexas 2014.
It's like a side, I guess, on thing. With R, like, unless you have some very obscure need, like, once you learn Python and the sci-fi stack, is there any point to learn R? Unless your employer's like, you have to.
Well, you can tell that to my statistics professor. I'm sure
I
you.
mean, all I've heard about is it kind of sucks.
Yeah.
R has a richer ecosystem of statistics libraries. So if you want to get some exotic corner case statistical algorithm, you don't want to write it yourself, maybe it wasn't well documented in the paper that described it, but there's an R library that implements it.
But it feels like each year, like increasingly so like MATLAB and R are increasingly having nothing like Python. But again, like, I guess it's in like crazy obscure stuff.
Yeah.
I mean, R scares me because in R, I love that you can take a vector of integers and treat that as an index on a table. And this would be like a permutation index. And so now I can go and grab the 10th, and then the 42nd, and then the 3rd, and it'll come back in that order. But if I give you an index of 20 numbers hitting some big table, and one of those numbers is a 0, I don't get an error back. I get a subtable with 19 rows. And no error, no warning. I don't find out about it until after the paper has published.
Yeah. And again, if you look at the list of packages available for R, it's very extensive, right? And I don't think this is even all of them. But like you also have to be very, very careful when you're using them to make sure that people are implementing their algorithms in ways that you would want to have your algorithms implement, right? But in short, I am more of a fan of Python than R, except when talking to my statistics professor who enjoys using R.
It does, even like in like obscure stuff. It's more so in obscure stuff. It's like, unless it's a well-trotted like library, you may want to question whether or not you should use it because, like you said, is it doing really exactly what you want it to?
Right.
Well, what if the paper that came out with that algorithm trotted out? Here's the reference implementation. That becomes the de facto definition of the algorithm, perhaps more so than the ambiguous prose in the paper.
So those are a few ways that you can use dictionaries. Has key, pop. So dict items. You can go through and get the items in a dictionary, the keys, the values, basically sort of ways to explore it. Sequences. You can slice and count through sequences. So a classic example is list, going from I to j via k, and list.count. So this is just going through and counting how many times it sees b. Yeah. And again, so all of these things that I'm showing, like they're specific examples, but if you are curious about any of them, just look at the Python documentation. Like I don't think they have this sort of going extensively through it, right? Like with this many examples. But they do have sort of generalized documentation about what each would mean. So iterables, n, not n, length of something. So length of an empty string is obviously 0. Length of this list is 4. Length of this dictionary is 2 because there's 2 keys mapping to 2 separate values. Testing whether or not an item would be in a dictionary, a list, and it returns a Boolean value. Sum, max, and min. Obviously does what it says, so it sums up the items in an iterable. If you're doing a dictionary, it doesn't do the values, it would just do the keys. If you have a list embedded, it would also add the items in the list. So zip combines, sorry, I thought I saw a question. Zip just combines the various things that you have look in the parentheses of your zip statement. So you would end up with those. Filter and reduce. And sets. So a set is an unordered collection without duplicates, and when printed, iterated upon, or converted into a sequence, its elements appear in an arbitrary implementation-dependent order. So it basically means the order that you put stuff in, that's the order that it's going to spit it back out at you. You can also enumerate across a set, so making a series of tuples using 0 through whatever. And you can see also that it returns a list preferentially instead of the value that you place into it. So if you have a string of A, B, and C, it will give you a list with A, B, and C specifically in that set.
With regard to sets, the most common things you're going to do is either adding something to a set. And so this would be, say, I'm reading some data stream. Here's a column, I'm reading it in, and I'm adding stuff into a set. When I'm done, I have all the distinct occurrences of whatever that was. The next thing that is commonly done with a set, just think like set theory, is testing for membership. Tests sets because they're
unions.
Sort of the same as dictionaries, like a hash map, but where the values don't matter. So testing if an element is a member of a set is an O1 operation. So imagine I've got 2 files, an input file, a filter file, and the main data file. I read the column out of the filter file, I got a set of distinct elements found. Now I want to take my main data file and just filter it down to the things that were observed in that first file. As I passed the first file, I was focusing on myset.add. As I'm focusing on the second file, it would be, I go if value in my set, then I'm interested in that record that I'm reading out of the second file.
Yeah, you can also do .union and .intersect, I believe, right. And that should, yeah, so.
Actual set theory.
Yeah, union, intersection, difference, and symmetric difference. So this would all be what Walker was discussing, testing the differences between different sets. And with mutations, so mutations would be after you had changed an initial set. So Yes.
After you get done with all that, can you turn it into an array to, do math on?
If it was numbers,
Right.
but then you've got to say, if I've got a set, and every element in the set was a number. That doesn't have to be true. You can have heterogeneous sets, but I don't recommend it. Then it's like, all right, I can turn the set into an array, but remember the set gives you things in no particular order. So I either just convert the set straight up into an array, and they're in random order, or I sort it. But whatever order the data was when it was coming in, if I'm just using native set, that's lost. And if it's lost, why are you putting it in an array? Because arrays usually care about the order of the elements.
Right, but I'm thinking, you can parse a large bit of data using those instructions, and once you're done with your parsing, then you can turn it into an array and start doing math on it. Like you have a large array and there's a lot of missing data in it, and you want to get rid of the missing data and then carry on with mathematical functions.
Okay.
Or impute.
Oh.
At that point, wouldn't you generally be interested more in NumPy's master array? Doing something like that?
Yeah, usually there's going to be a better way of doing that. If I'm using a set to process, like a big array, and I don't want to use NumPy machinery, and set is involved, I'm probably using set as a filter system, where I'm just going to filter, use a set for some reason to filter things out. I might have a set of samples that are known bad, and here's a big file that includes those samples but have lots of data that isn't in those samples. My bad stuff is just mixed way, way down there, and I want to very quickly load this in as quickly as possible into my NumPy array. Then I might load the data one record at a time, filtering against the set, and only add to my NumPy array the stuff that survived.
That would be the best way to do it.
Well, that's how I see using a set in a situation where I'm also using NumPy. Is that's the obvious reason. If I'm going to, why would I use a set in NumPy? Well, that's the obvious reason for it. And probably what's in the set that I'm filtering by is not numbers but strings, like wellhead IDs or something like that. It's like, well, I want to exclude these.
Yeah. Or any lease data that's not expiring immediately, something like that. You can also add, remove, discard, and pop items from a set. And if you look, it preferentially pops out the first one, I believe. So if you type in, if you have a set and you type in pop, seen right here, it'll tell you what it popped out, and then if you print the set again, it would do that. And that's different than the sort of pop that we saw expressed in the list. You can also check to see if particular values are a subset of other values, and it would return a Boolean. So if it's a subset, if it's a superset, or if it's a copy, or if you would, yeah. So graphics modules. These are specific to things that you can do in Code Sculptor. So for example, the simple GUI that we saw before, these are various ways that you can manipulate it, right? So the first two entries are the syntax. So you import simple GUI, that's at the top of your script. And then you would create a frame with a title, canvas width, canvas height, and then also a control width, if you would like. You can set the background color, change the interactivity, and get the canvas's width. You can also have control objects, which are placed in the control panel, and they're top-down in order of creation. So you can add a text label, a button, text input to the frame, get the text of a control object. And this again is all just Code Sculptor documentation, right? So set the text of a control object, which would be like a button. The keyboard input handler, mouse input handler, and then canvas. So again, this is all just additional functionality that you can play with within Code Sculptor. Canvas drawing, so drawing a polygon, drawing a circle, a point. Timers, so that would be specific to what we saw in the Dance Dance Revolution video. You could create a timer, it would have an interval, and based on whatever interval you set that timer to, you could have it perform a certain reaction. And Walker's done a lot of work with Pygame, right? Like, would you use...
A while ago. So, yeah, Pygame is the closest desktop equivalent. And the point with that is that every game is similar to like a simulator, where you have some state space, some collection of variables that are going to change over time. Say, the position of a tennis ball. And you have a concept of user input, and you have a concept of rendering to the screen what the world looks like. And that same system can either give you some stupid game like Pong, or it can give you a flight simulator. It's the same model view controller machinery. Well, that loop. In order for the physics engine or your game simulation to be sane, there must be a concept of time between the two loops. If you just said, my tennis ball is moving 1 pixel every time I go through the loop, regardless of the speed of the computer, then you get to these situations where, like the old 8-bit games that are unplayable on today's hardware, or 16-bit games that are unplayable on today's hardware because the computers are too fast. And they never thought about how much time had actually passed between one and the next. And so the bad guy shoots something and it's there, but I didn't even see it, much less dodge. So games instead say, now, I'm going to have a timer there, and that's going to tell the game engine how much time has passed since the last time you were at the same spot, so the tennis ball only moves that far. But also, optionally, can limit the speed at which the game is simulating. So if you give it a faster and faster computer, at a certain point, there's no point making the simulation any smoother because it's already as smooth as the human can perceive it. If you make the game loop go any faster, you're just burning up the battery on the laptop, causing somebody's pants to catch on fire. So every game engine has to have some kind of timer concept that is going to limit the speed at which that loop is going to go, and possibly also capture the amount of time that has passed, so that delta t times v equals delta x.
And then ways to load images before drawing them. Sounds. So also, sounds are able to be downloaded. This is documentation from Code Sculptor's site, right? So the song that we initially saw or initially heard playing is located in this area, right? So common data storage, Google APIs, Code Sculptor assets, and then there it is. So you would be limited to things that are loaded into Code Sculptor's libraries. But I think you might be able to direct it to other locations. I'm just not sure. You can set the volume, you can play it, pause it, rewind it, depending on click events. Maps, there's also a utility called Simple Map that you can download, and it gives you title, coordinates, map width, and map height as sort of parameters for your initial function. The one that I have documented on this slide deck, or potentially last time slide deck, was an example of Rice University. So that's the latitude and longitude coordinates and how large you want your square to be. So you can also add polygons and lines to a map within Code Sculptor, and markers. So there it is. But yeah, so you would see an example of a marker, the line, and how you can have a route from one to the other. And again, it's not a perfect route. There are corresponding libraries that you can use with your own version of Python. I wasn't very sure what the audience levels would be for this tutorial. So if you'd like to talk about things like PyGeocoder or how to incorporate the Google Maps API, like that would be something that we could discuss later on after the workshop. Does anybody have any projects that they're currently working on with Python? Yes.
With maps?
Yeah, go for it though. Like what are you currently working with?
Well, taking a data set of historical batch data, and I am doing principal component analysis and partial square on it, and visualizing the results and using that to analyze, what corresponds to a good batch and what corresponds to a bad batch.
Mm-hmm. And this is chemicals, right? Batches of chemicals.
Well, it can be food and beverage, it can be pharma and biotech,
Mm-hmm.
and any sector that runs batches.
Okay, cool. And is in, yeah.
Well, taking SVG files, graphic drawings, and animating them, like artificial intelligence brain science diagrams, and animating them so that then I can do a voiceover to explain things. And I'm not really an expert on that. If I tried using Blender. Of course, Blender is pretty complicated. But if I export files from my canvas, it loses all the hierarchical information in the SVG, which is unfortunate. It's nice to have that hierarchical information on us, the extent to which you have grouped items. But I don't. Would this Pygame be good for that?
No. So Pygame is all about game engines or some kind of like multimedia type environment. It's all about, and 2D specifically. So it's about pushing pixels to the screen very fast while accepting input from keyboard, mouse, or joystick, and playing sounds.
Right.
Similar to what Paige was showing you, like the things that you can do in the Code Sculptor demos, you can also do in Pygame, but their graphics are all about pixels in both
It doesn't do
worlds.
vector drawing.
Right.
Right. So again, though, this is sort of a generalized demonstration that Google is your best friend. So let's see if we can.
Are you going to Google Python space SVG?
Yeah.
Oh wow.
Let's fingers crossed here.
Or it was supposed to be animated? SVG animation.
Animation. Yeah. So an animate
The
SVG.
SVG files, it just loses all the hierarchical information.
A Python library to create SVG drawings.
And
So.
also, could you Google Python space plot device?
Mhm.
I think that's it.
Scriptable graphics factory.
Scroll. Because I think this one does animations.
For
Yeah, it is.
vector
it's
PDF. Yeah.
I'll keep going.
Mhm. Let's see. SVG animations using Python. Yeah, that's. And then it also leads to Stack Overflow, but it's mostly pointing to the animated SVG support and SVG write. So that's another another sort of instance in which basically if you're learning a new programming language, and Walker mentioned this in the last workshop, your best bet is usually to just Google whatever you're looking for and the name of the programming language. And 10 to 1, it's going to lead you to the program's package index or library documentation, or it's going to direct you to Stack Overflow. Like those two places are some of the most valuable sites on the internet. And there's the SVG write animate documentation. Cool. So does anybody else have projects that they're working on? Yeah.
I've got a map that I've built, a GIF file,
Uh-huh.
and then I'm using the Perl library to draw little circles that are different colors.
Right.
And what I'm doing is I'm reading alarms and traffic signals all over Dallas West,
Mm-hmm.
and then I'm painting the color on this map to display alarms like the traffic signals and flash. There's different problems.
Mm-hmm.
Could I use Google Maps to do the same thing?
You should be able to use the Google Maps API, I believe, as long as you have latitude and longitude coordinates for the things that you need. But yeah, and there's also something called OpenStreetMap. If you're just looking for something to overlay these points on, yeah, this is an alternative to Google that is actually quite. It's been gaining traction, and it's got gorgeous imagery, right? And obviously created by people from Europe primarily, because they start over here in Europe instead of over in the United States. But yeah, you can change layers. So standard, a cycling map. MapQuest, OpenStreetMap, transport. This is also useful if you have a GPS. You can download mirror files of the maps that they have, the street maps, and load it into your GPS map if you have an outdated version. Like, so a friend has a GPS from around 2000, and obviously infrastructure is, or maybe a little bit later than 2000, but obviously infrastructure has changed in that period of time. But the maps haven't really been updated, and it doesn't really have support to update the maps. So if you download some from this site, you're capable of updating them by yourself. And they're usually quite good. So anything else that people, yeah?
I mean, it's mostly me just like messing around.
With your trillion iterations?
Well, that was an afternoon. I mean, like, mostly something I'm doing is involves a number of things that I want to learn. Like the first step is like I'm creating modules that gather data that I want from Anaconda APIs, like current data and stuff like that, and be able to gather it throughout the day. And then I'm going to create like an auto trading system that utilizes that. And in theory, like, I don't know, like if I ended up like looking at like running like a server online using Twitter data, it's like influence trades.
Okay. So it sounds like you're trying to do a lot of stuff. What packages would immediately come to mind for you? Like,
So you're getting financial and what else? Twitter?
Yeah, Twitter. That one I'm still kind of thinking about. These are just complicated.
So you're just pulling data from different strings over the web.
Yeah.
Okay, so you're using like requests in order to fetch the data.
And then using like machine learning to like process it.
So that would be like scikit-learn. So that's, so I don't know if requests is bundled with the distributions, but that I think is pure Python. So it's like, so in the Python standard library, you've got URL-lib, URL-lib, and URL-lib2. And you should be using the URL-lib2 if you're just using the standard library. A mechanism which, given a URL, will go and fetch it for you. But there's something better called requests.
It's way better.
Right. So, all right, so you're using that. And that one's an easy install. Not necessarily easy underscore install, but just, pip install requests. because you're trying to get machine learning in there, you really want to be using some of the stuff like the scikit-learn. So that means you probably want a distro, which means Anaconda or Canopy, that's going to include SciPy and scikit-learn.
That's when I started out.
Canopy?
What was your, like, what is like the best library for dealing with CSV files?
For what?
CSV?
Like,
Well,
let's say,
there's,
like, you don't have a CSV document, like, it's not, because whenever you import, let's say I have like 50 stocks, and I want to import current data, string current data from it. Whenever you do that, like, in order to not have like constant, like for each, if I didn't want to call their server for each individual stock, like if I want to do it in one
You
bulk
may ask
call.
the server to give you a CSV dump in one step.
Yeah.
And now you've got a
So I
CSV
have-
file.
What is the most efficient way of doing that? Because the way that I have it in my
How big is it?
lookup
How big is the CSV file?
What is it?
how big is the CSV file?
It's not big, like, I mean, it depends.
If it's
It
not
depends,
that
like,
big,
currently I'm just doing.
The standard library version
yeah,
just is,
built-in. Okay, so in the built-in standard library, there's the CSV module. Now, CSV is not a file format. CSV is a large family of possible formats. Because are the columns separated by commas or are they separated by tabs? Are strings quoted? Are they not quoted? What are the quoting rules? What happens if the quote character appears inside the value of one of the things, and how does escape happening? And every possibility, somebody has done that. And so the CSV module supports all those possible dialects, at least as far as a bunch of switches that you can flip. And so first you have to download a sample, look at it, determine, what kind of jacked up CSV is that particular website generating, so you can set your switches right. Then you're set. Use the CSV module to create a reader. It could either be a regular row reader, which gives you a list at a time, or a dict reader, which gives you a dictionary at a time.
I guess afterwards, like, if I show you what I have, is like, it just feels like there should be a better way of directing how they
Premature optimization is the root of all evil.
I'm not talking about optimization. I'm just saying, like, simply put, a better way. Like,
Okay, well, the better
I
way
don't know
is,
how to express it.
if the code is fast enough, then the best way is the way that is the cleanest, most idiomatic, easiest for someone else to read. What's that?
Like, I'll just show you later.
You want a code read?
Yeah. Like, it's not clean or idiomatic. Like, it's
Would your answer be the same if it was a very big size CSV?
No.
No.
A different answer.
What's your answer?
So if you've got a big hunkin' CSV file, so that the pure Python approach, which the CSV module is going to do, is not a good fit, then you should use some library that's bundled with one of the scientific packages. So for instance, Pandas has a data reader. And what you get out of that usually be a data frame, which is a collection of NumPy arrays. There's probably something in NumPy for reading CSV directly that I don't know about, but you'd want to do something like that. Of course, if it's really 30 gig, I have to ask how much memory does your machine have.
Okay, it's my friend's issue. Yeah, it's gonna be spending.
Okay. If the CSV file had to be transformed before whatever library you're using could read it, so the advantage of the CSV module is that it's very general. It can read anything. If you've got one of these more high-performance CSV readers, it might be less flexible. So you might need to run your CSV file through a preprocessor. Take the 30 gig file and in a very fast step, transform it into a different 30 gig file before it can be slurped up.
so it's read_CSV. I think that's what it's called. There you go.
Yeah, but then you definitely, at that size, you don't want to deal with Python lists anymore. You want everything to be NumPy arrays.
Yeah.
Maybe not directly, like in Pandas, everything's a NumPy array, but it's like one layer under it.
So I guess that sort of leads to the question again. It sounds like a lot of people are doing work with large-scale data or scientific data, or trying to do something with untenable amounts, but not to the point of not to the massive amounts where you would need something like C. So could I see a show of hands again? Who has Anaconda or Canopy downloaded to their machine? Okay. Who would like to get Canopy or Anaconda downloaded to their machine and play with it a little bit? Like if it has data capabilities that you don't.
What is Anaconda?
Anaconda is a continuum analytics software package, and you can actually go and ask those nice people out there too what it does. It's free. Uh-huh.
They probably have it at the keychain drive, so you can skip it down.
Yeah, that might actually be. But yeah, so Anaconda is a Python distribution that is exceptionally powerful at dealing with Python packages. And it also allows you to do specialized, lightweight virtual environments and mathematical and scientific analysis. The other thing that Walker was mentioned, and that I think he uses, is InThought Canopy, which is free as well. It's a great alternative to MATLAB and Mathematica if you don't want to have to pay for it. And if you have a .edu address, it's also free for a kind of souped up version. But yeah, if anybody would like to get these two installed onto their machine, we would be more than happy to help.
If you love the terminal or like the terminal, go for Anaconda.
Mm-hmm.
If you kind of don't really like the terminal, then Canopy's a bit better fit. But Anaconda is also more Python 3 friendly. So that makes sense.
Yeah.
Python 3 friendly.
Mm-hmm.
So with all these flavors and libraries that you need to have associated with but the idea of code review and people now using free versus having access to cheap, isn't that a big issue? Is making sure that the bindings are all aligned and trying to make sure that code is scalable in some sense and just current or maintains current, especially if it's a large project or a very collaborative project. What do you advise for someone who's just barely getting started? I heard you say 3, but yet trying to maybe help with some older code that you want to make it more universal, or I'm not sure exactly how to describe it.
Well, if you've got a large code bases too, that could be a reason to be working with 2.
Mm-hmm.
One of the most important factors in selecting the technology is, actually in many cases, the merits of the technology is the second most important factor in selecting the technology. Sociologic and economic concerns are usually the dominant factor. So, like Paige, you had to deal with some old version of Python because
Yeah, I can actually show you. But in all honesty, for example, in the oil industry, the majority of people who are working as sysadmins have experience with a language called Perl. Has anybody ever seen Perl code? Yeah. Perl code kind of looks like a computer threw up onto a screen. It doesn't have any standardized, it doesn't have any specific structure. And I'm sorry if we have Perl fans in the audience. It's kind of like an alphabet soup of things that potentially the computer understands, and humans definitely don't. And also it doesn't give you any feedback. If you can type basically anything and it'll probably run, and it'll probably give you an answer, and you'll get the answer and you'll be like, oh, hey, yeah, awesome, I got an answer. And it's not the correct one. But yeah, so the majority of the point that I was trying to make is that the majority of scripts that are running on company servers are all Perl scripts. So you have these archaic things that were written 20 years ago, and somebody wrote them. That somebody is probably not still around to explain it. It's not very well documented, and it's doing something important. And instead of turning it into a Python script that people are, have experience with, you just keep it around because Perl is what's always been there.
Well, maybe wrap it, encapsulate it in some larger system. It's the small protected piece that never has to change. Nobody wants to touch it.
Uh-huh.
So that's then the next question is, what do you advise? Are you involved in talk about your experience of that specifically? Like, there's a larger effort to address that old code that maybe should be more standardized.
Right. And that's always a project management decision. I see where you're going with this. But yeah, it's basically built around, okay, so you have an older technology. How do you transition to this newer technology? You do it all the time with software. Like, how do we do upgrades? And see, there's 2.4.3. Told you.
I didn't like it.
Yeah. However, if you operate on a Windows environment, you are capable of getting 2.5, 2.6, and 2.7, but that's about it. And that's only because that's what integrates with ArcGIS. And that's the only way that I was able to persuade them to let me use it. I promise my job is great. But yeah. So if we're so concerned with safely upgrading to new technologies, right? Like every time a new version of software comes out, we have a plan, we have a process to implement it, those sorts of things. It seems kind of counterintuitive that you would have these old scripts that are doing something that we need them to do, and nobody really takes the time or is motivated to have motivated to make the project happen where you upgrade to something new and something more that has more capability. Yeah.
I think a lot of the problem with this is that, especially in the corporate environment, software isn't viewed as an asset that needs to be maintained. It's kind of written, and if it works and it does the job, then it's just kind of put off on the shelf and left. We're having this issue in my job specifically, where I've got code, part of it's in MATLAB, part of it's in Perl, part of it's in Fortran, written by 4 different people over the last 15 years, that's kind of been cobbled together and added on to. And the question that I've got to ask my manager is, would you rather have someone devote 2 to 3 weeks of this every 6 or 7 months to kind of maintain and keep it up to date, or would you rather have someone spend 6 months on it once every 4 or 5 years?
Yeah. Yeah.
So where I work, what the decision was, is here's a pile of code that we didn't actually need to change because its use case was never going to evolve. In fact, the use case was sort of slowly dying, but it would take like 1 million years for it to die completely. So what they decided to do was to make a virtual machine that would have the old operating system and all that software and just encapsulate it inside a virtual network like the Matrix. It's 1988 forever. It's never going to change. And the software will never suspect that time has passed. It's just going to see inputs and do its outputs, and that's that.
So I guess what I'm hearing too is like there's the technical challenge of learning. An example of batch data that you would be getting from your thing? Okay. So batch number, batch data.
Am I zoomed too much, or is that good?
That's good.
And
Let's see. I'm sorry.
So if I can, I just want to take the the reading of the data that defines that CSV, read it into a function, and have the function execute the next 1, 2, 3, 4, 5, 6 lines of code, and then, you know, return the reordered array. That's it.
Okay. So,
Okay, so this code needs several rounds of extract function. Like, first off, an idiomatic Python script should really have, if it's non-trivial, should really have a function called main. And then that main function should itself only be about 1 or 2 screens max. And so it should then be broken up into sub-functions that it's calling. Right. So this is like a big polynomial that just needs to be factored into its components.
Right.
yeah. So I guess that's what we're going to be doing.
Well, that's your choice. It's your show. What do you want to do, boss?
Well, I mean, we could work with you after this. I guess we're done with the rest of this presentation. But yeah, if you want to try to.
I mean, so let's see. There's
How many functions? So there are variables declared at the beginning for
Yeah.
I and range. Capture one block of batch data at a time.
Yeah, so, I mean, well, actually, you could kind of see that these major sections here are probably going to be, would want to be factored out as functions. You know, so once he did this, that's probably going to be a separate function. There'd be, well, this should move down after the imports. And would really be in a main function that would bundle that, as well as, at least initially, everything down through loading the data.
Yeah.
And then calling the stuff that came after. So starting from here on down would be some analysis function. Then there's probably going to be an output. Yeah, so here's the main crunch. This is where he's doing his primary crunch. And then at some point there's going to be an output stage.
Well, if it's importing matplotlib, any import statement should be declared at the beginning,
Yeah, that should go to
right?
the top.
Yeah.
But down here, there's like an output stage. So generate plots. Clearly, this is going to be a separate function. And
that's still plotting.
yeah,
So all the end portion, there
would be the plotting.
yeah.
So at a minimum, there's like 3 or 4 functions. You know, main could just be like calling those functions. And then later on, I'd want to come back and ask why. Notice that he does this initial read, does some crunching before he reads the second file. Is there a way that that could
Be consolidated.
right?
Yeah.
So that there'd just be input and then 2 different rounds of crunch, you know, or at least separate this part here in reading that file from the initial crunching on that file. Those 2 concepts should be separated. So I see the blueprint of it,
Yeah.
but is that what I mean, does everybody understand what we just described about what should happen to this script to make it better?
We probably should have spoke up. Like,
You know, the import should all cluster to the top. There should be a main function that's fairly lightweight, that's just the pointy-haired gloss saying, read the first file, do an initial processing of that first file, read the second file, and so those lines where you're just reading the file, they can stand by themselves, not as separate function calls. Do the major crunching, that would be its own function, and then generate the plot. And that's a huge function. They would probably want to factor that out into bits, like set up the axes and
it's
so on.
the entire.
And so at the end, there'd be about half a dozen different functions that would be here. And the goal is you want any one function to, at most, fill up about a screen's worth. And that's not because that makes the computer any better, but this is the expressivity problem. A program is as much a document to other human beings as it is to the computer. Now, that other human being might be a future version of yourself, but this is why modern English, the modern practice of English tends towards the usage of short sentences and short paragraphs that are bundled into short chapters. So it is with source code that you want short functions bundled in relatively short files. And each function should have a name that is sort of descriptive about what it does, and it just focuses on that one thing. You don't want any one function to do too many different things. Really, you want one function to do one thing.
Are there any resources or tools that folks can go and take code like this and understand what maybe some of the best practices are?
Was it PyFlakes?
I think that's right.
Yeah, so there's a couple things. First, there's PEP8. So who here knows what PEP8 is? Okay, so for any given language, whether it's a human language or a computer language, there is the grammar of the language, what is supported by the dictionary and the grammar book, and then there is the language as it is and should be practiced. In the case of programming, that means that a language has its grammar, and then there is idiomatic code that is consistent with the culture that's evolved around that language.
There's also
Idiomatic Python code is called Pythonic. PEP8 sets a standard for what idiomatic Python code should be. Somebody wrote a tool called PEP8 that actually checks your code against that. Now that is just a style check. That's not checking for all of the stuff we're talking about. It would complain about the imports that were deep down in the program, but would not be complaining about the lack of functions. It would complain about spaces that come after the end of the line, so that round of dots right there. So it's going to complain about certain stylistic things. To go deeper than that, to look at things like variables that are declared and never used, or imports that are never used. There are tools called PyFlakes. That's it. That's the job of a linter, a program that's not just checking your code for style, but also for suspect behavior.
Yeah.
What are those called?
PyFlakes. Flakes, like snowflakes.
I guess that'd be like the flakes of skin that come off of Python.
Yeah. There's also a book called Writing Idiomatic Python by Jeff Knupp. Yeah. And
a
it's
video series where he's got three episodes of right now. He takes poorly written Python and he refactors it on screen in front of you so you can see the choices he makes and all that stuff.
Yeah, he also, I purchased the ebook, so I can find it somewhere in my Gmail if you guys would like to see it, but it has sort of a never-ending updates thing, so if he makes updates to it afterward, he'll send you a new copy.
Oh, cool.
Yeah.
So one thing about this. So if you don't have unit tests, this is where you need at least a functional test. I would not tackle this until I had gotten some data from Peter and had generated the output, and then I would be periodically comparing the output of the new version of the program, as I'm going through steps, against the generated output. And I'd run that over and over again. That's my safety net. Because there's lots of opportunity to break this code as I start rearranging pieces and renaming things. I'm doing all this stuff, and is any of it still working? And well, the answer is no, unless I had some test data to be checking as I was going. And the other thing is that as I'm going, what if I do break it? Now I want to back up. And so I would want version control. And so if you're not using a distributed version control system already installed, you should get one.
Git.
Yeah, the Python core developers prefer Mercurial, and for the purpose of this conversation, it does not matter. You have to get one installed and start using it. Because you don't need to be having a server, you don't need a GitHub account even for this. It's just, I create the directory, I initialize an empty repository, I add the initial version of this code to that, along with my test case, and save that, make a commit of it. You know, I've planted a flag in the ground and say, this is my safe, or better yet, to think of it as like a spike in the rock face, a piton with a carabiner on it. You know, I've got my safety point. And as I start hacking on this, periodically, you know, whenever I take a breath, and, that passed. Bang, 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 bang. Another safety piton, another carabiner. So I've got this safety line that's always tracking me as I go further and further along with that hack.
Well, so then my next question would be, to develop the initial code, is it better to just write one long thing out, and then once you get the answers that you're looking for, then you start factorizing it?
It depends on your problem. While you're still figuring it out, long run-on code is reasonable.
Yeah.
But then whenever you finish a section and it looks like this part is good, it's time to be thinking about, I should encapsulate that as a function.
Yeah. It's sort of the, do you not clean the house until Christmas rolls around and then you have to clean all of it? But yeah.
So I guess, well, you'll be in touch with me.
When's the next Pi Houston
You need
meetup?
this,
No, it's fine. So again, Writing Idiomatic Python by Jeff Knupp, and that's K-N-U-P-P, I think. It's a good book.
I guess so.
Yeah, I guess. We're letting you out 30 minutes early. Unless anybody has any questions.
I want you to keep talking.